Welcome to Module 5. The code for today is what's the object-oriented way to become multi? Basically, inheritance. Okay, today is going to be somewhat of a tough module. There's a lot of concepts that we're going to try to squeeze in. Okay, and aside from that, I'll be switching with TypeScript and also JavaScript, and also to an online editor of JavaScript. Okay, let's start with classes. Okay, let's start writing. So to create a class, we use the keyword class, and class are basically like a blueprint. Okay, let's say you want to create a building, you need a blueprint. The class is the blueprint of the building, and the building is the object. Okay, so going back, let's just say we have a class A, it's a greeter class. Okay, and inside the class, we can put a variable called greeting, and we want the value to be a string. Okay, next is in classes, we usually also create what we call constructor. This is also a keyword. Constructor basically means whenever you create an instantiation of a class, meaning an object, you pass the constructor would initialize some of the parts that's already needed. Okay, so let's say our constructor would be message, which is also a string. And basically this means if I create a new class, a new object greeter, I must pass a string parameter. Okay, so far so good. And this. Okay, this is another keyword. It's super hard for both new developers and even seasoned developers because of it's super flexible. But right now we can just limit the scope and explain this. But this keyword only refers to the object. So this dot greeting just only means greeter dot greeting. Okay. So that's our constructor. So aside from that, in our classes, we can create methods or APIs for that. So let's create a method. Let's create a method called greet. And what it does, it's gonna return hello plus this, which is greeter, greeting. Okay, so this is a fully working class. Next thing we do is we can assign that we're gonna create a new object from that class. So the way we do that is you invoke the new keyword, and after that, the class name, this. But it's not yet done. It's saying an error. Says expected one argument, but got 0. It's because we defined a constructor that says that, hey, whenever we create an object from class greeter, we are required to have one parameter. And let's say, hello, CS142. And then let's try to log that out. There you go. You get the CS142. Okay. Now let's try to define some of the things. Greeting, which is in line number 2, it's basically a property of the class. Okay. Greet is also a property, but this is a method of the class. Okay. Greeter is just a variable that we assign with a new instance of the class greeter, which created a new object. Okay. This refers to the member class and denotes member access. Again, just to make it simple, this would just refer to the class. Right from the bat, you can see down here. We'll dig on this later. Okay, but as you can see, there's no classes in JavaScript. Okay, I'll explain more what happened. So right now what we're trying to do is object-oriented programming, class-based approach. But something to note that it just helps people who had a background from class-based object-oriented programming, who have done C++, Java, and such, so that it's easier learning curve. But underneath the hood, it is a prototype-based object-oriented program. So this is what we call in the syntax sugar. Okay. Next, let's talk about inheritance. So let's create a new class. Let's create a class animal. And then the class animal would have a method. Let's say it moves. And let's say it has a distance meters, in meters, yeah. And we initialize with the value of 0. It's a number. So if you remember in functions, again, methods, functions, saying banana, in functions, you can define the type and also put a default value for your parameter. Okay, and then let's just have a console.log and backtick so that we can use the variable. We access the variable with the $sign and then braces, and then the variable name. And then afterwards, let's put M for the meter and a dot. Okay. Now, when we talk about inheritance, it basically means that you have a class and another class can inherit the property. So an animal, a dog can inherit from an animal class, right? A cat can inherit from the animal class. So let's do that now. Class dog, how do we inherit? We just have to have the keyword extend. And now if we have that extends, we just need to name what class we want to inherit from. And we use the animal. Okay, and now the dog would inherit the properties of animal, so it will also have this move function. But aside from that, you can also create your own functions or properties. Bark, dog can bark, so console.log rar. Oh, wolf, sure. It's like I've never seen a dog in my life. Okay, so now we successfully inherit from an animal class, and let's try to assign to a variable, invoke a method, and assign a value. Okay, first things first, let's create an object of a dog. Remember, this is just still a class. It's just a blueprint. Okay, we want to clone the dog, even though it's not ethical. So again, to create an object or to instantiate that one, is you use the new keyword, and then the class, and then that one. And as you can see, we don't really need to put parameters because we didn't ask, like both of them doesn't have a constructor as well. Okay, constructor means you have to initialize. Okay, but they don't have constructor, so it's fine. Next would be, let's invoke the bark. Woof, woof. Or woof, woof. Okay. Aside from that, because it has the properties of animal class, so even dog is able to move. The animal move 10 meters. It's that fast. And then you can still keep doing the bark, 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 because your dog is so loud. Okay. Again, recap. Classes inherit properties and methods from base classes. So now we can define that the animal is the base class, and this class inherits from that group. Okay, so it inherits the properties and methods. Now, we also call dog as a derived class. It's derived from the base class, okay? And you use the extends keyword. It's also called that the derived classes are also called as subclasses, and we can also call the base class as parent class or even superclass, okay? Because dog extends the functionality from animal, we were able to create an instance of dog that could both bark and move, okay? There's a more complex example that we're gonna pass for now. Next is we'll talk about public, private, and protected modifiers. Basically, these are interfaces. When we say public, and anyone can access it. Private, only the same class. Protected, you could access it from another way. Okay, let's do this again. Let's have the class animal. And in that class animal, to define a public, we just put public keyword. And let's say it should have a name, and it should be a string. Next, we create a constructor. And inside the constructor, we have should have the parameter called the name, and it's a string. Okay. Inside of that, we have the this dot name equals the name. Okay. This is just animal, so it's animal dot name. So what happens here? If we create an instance of animal, whatever we pass as the name will be assigned as the name. Oh, so weird. Without the name. Okay. So aside from that, let's just make this, I guess, cleaner. Put this here, or maybe not. Okay. Next is we can create again a public method. Move. And we can move again distance in meters. And we want that to be a number. Open braces. And we can create a console.log. And again, backticks, because we want to access variables. Name. And then move. And then we want the distance again. What's the distance in meters? And then end and the. Now we have to, we don't need to invoke it yet. We're just showing you the public method. And now, if you want to create a private method, let's try just putting this to private. Okay? And then let's try to access that variable. Let's say you have a new animal, and that new animal is a cat. And then let's try to access the name, doesn't let us. Property name is private and only accessible within class animal. Let's try to make this public. And now the error goes away. Okay? And the other example is, let's say, do we remove this? Should we remove this? Okay. Class animal, and then let's create a, sure, class rhino. It extends from, again, the base class, animal. And then let's say it has a constructor and it's super, okay, we're gonna use the super. So super, again, it will be basing the super class, okay, the super keyword. Okay, I think we should remove this for now. Maybe this one as well. Constructor. Cleaner, private. Okay. Let's create another one. Employee. Ooh. Okay. So an employee should have a name. and it's a private. It's not accessible outside, so it's a internal interface. It's not an external interface. And let's say the constructor, we also want the name parameter as a string and assign whatever we get, the name. Okay. Now let's try to use those classes. Let animal equals, let's create a new instance of an animal, create a goat. And then let's create a new instance of a rhino, new rhino. Also, let's create an employee equals new employee, Bob, boss. Okay, animal equals rhino. So we're just trying to assign the rhino object to the animal object. And you can see right now that it would allow us to do so. But if we do this, animal equals employee, it doesn't allow us because employee is not assignable to type animal. Types have separate declarations of a private property name. Yep. Again, why? Because it's not a derived class from the animal class. Okay, so you can't assign it to that variable. Okay, let's talk about protected. Away from animal, person. Just if you want protected, you just put protected. Let's have a name. Should be a string, and the constructor. Also put name, string, and define the body, and we assign whatever we get. Also, let's create the employee again. Class employee. We want it to extend from the base class person, and inside of the class derived class employee, we want to have a private string called department, and then we create another constructor and the name string, and we also want to know the department of that employee, so it's going to be a number. Now we can just put a string. Okay, inside the constructor, we want to get the name from the base class. As you can see, it allows us because it's a derived class, so it should have access to the base class. Okay, super name this dot department equals department. Okay, let's try next. Let's move on for now. Public, say get elevator pitch, and then return backtick. Hello, my name is this dot name, and I work in this dot department. Let's see, it's not being used. Department, typo. There we go, fix that one. So let's try to make this bigger for now. Next is let's try to use them. Let Tony calls new employee, create an object employee from the class employee, and we want to create a name for him. And let's see, Tony start. And then let's say he's in the what department? Weapons department. Okay, so let's try to check if we can get the Tony's dot get elevator pitch. Console.log. We check also his name. I think this is for later. So hello, my name is Tony Starks, and I work in weapons of mass destruction. Actually, no. Walls of Jericho. I think he did that. Okay, so let's try to comment this one. And now we see this error. It says here, property name is protected and only accessible within class person and its subclasses. Why is that? Okay. Again, because it's protected and it's only protected and only concerned and blah, blah, blah. Yeah. Because again, I think I should get more information on why, but basically it's kind of halfway private. Private has more restrictions, okay? And there's another thing. We can also have the read-only, okay? Let's create a class octopus. Let's bring this up. By the way, this is the code. This is the JavaScript code. So who's loving TypeScript now? Like, whoa, 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 what's this? Okay, let's do octopus. And in the octopus, let's create a read-only variable or a property. And let's also create a read-only number of legs. And number of legs should be a number. And let's put a default. Go ahead.
What TypeScript house is it called? PS5 JavaScript or PS6?
You can point your target, actually. Right now, the target is the PS5. That's why it doesn't have it. And you can see you brought it up. So even JavaScript already implemented this class-like structure and ES6 onwards. But again, it's still sugar syntax. Underneath the hood, it still uses this one. Okay. Read only, and then we have constructor, name again, string, this dot name, it's this octopus name, the name. So let's say your dad is a new octopus man with 8 strong legs. Okay, let's try to get the name though. That name should be fine. Let's log that out. Yep, that should work. And now the question is, what if we like to assign a new name for your dad? Because you don't like your dad's name, you hate him, and you have daddy issues. So, man, read the 3-piece suit. You don't really even give him a name. So it's going to throw an error. It says, cannot assign to name because it's only a read property. Okay? We've done public, private, protected, and then let's, we also tackled read only. Let's go with accessors, okay? Accessors, basically you would have what you hear all the time, those getters and setters. So the getters, what they do is just they get something, okay? The setter is when you invoke it, you want to change the value. You set the value. When you say get, you just get it and consume it. That's it. So let's create class employee again. Full name. String. Let employee. Oh, small employee. Create a new employee. Doesn't need a parameter. Employee dot full name equals let's see. Don't, oh no, I can't spell. Never mind. I can't spell. Okay, if, let's say, employee dot name, that full name, sorry. This if statement, I don't know if you encountered it. If you don't have any valuation, like less than equal sign, double equals, triple equals, what this says is if it is not undefined, or is it true, or if it exists, it's just a shorthand. Yeah. And let's see. I think I missed the part of the getters and setters. Okay. Oops, not that one. Okay. So, okay. I think I have more getters and setters down here. I think I did not have the full code for this one. Apologies for that. Okay. Let's move on to static properties first. Okay. Static properties, basically you have a, let's say, class grid, and you get the keyword origin and X and Y. So your origin is an object. You have the key X and the value of 0. And then let's say you want to calculate the distance from origin, point X number, Y number. And then let's create a variable named xdist, meaning the distance of X. And we want to calculate that. So it's going to be point dot Y minus grid, and X is the origin, and also put dot X. Okay. Try to do the same. Y. No, this should be Y. Okay. Same one. And let's do a mat function. And the mat has an API called square root. And then let's pass the parameter xdist times xdist plus ydist times ydist. Okay. Constructor public number. Oof. Now let's use them. So what are statics? So basically, static members of the class, it only means that you don't really have to create an object to access it. Okay, so let's try that. First, let's try the normal way. You create a new grid object. Let's say you put the number. Create another grid object. Let's say you go number. Looks fine, no errors. Okay. Also, we can try using the method refresh. There you go. Okay. Next, abstract classes. I can just show you what abstract classes are. Use the keyword abstract, animal. So if classes are your blueprints, now the question is, how do you create the blueprint, right? You should have a template. So the only thing you have to know about that is in abstract classes, you can't really create an object from them. You can only create subclasses from abstract classes. Okay. Abstract, make sound, void, move void roaming the root. There you go. That's it. I don't even need to run it. Okay. Again, let's try to recap a bit. Private methods are no. In object-oriented programming, we always have two interfaces. One is the external. Again, should be public. It could be accessible from other methods of the class, but not from the outside. External interface, methods and properties, accessible also, no, internal. Again, I repeat myself. External, basically public. Internal, just within the class. Don't need to explain more. Okay, a good analogy for this one, though, what I found online is the coffee machine. So every morning, Seattleites are very addict with coffee. So they go to the pantry and have this coffee machine. And what do you see there? You just see the, what do you call that? Because I don't really make coffee. The pot. You have the pot, and you have the switch, right? So those are your external interface, public interface. You don't really need to know the internal. Why? Because again, in code, it could be dangerous if you mess with the internal. Same with the coffee machine. If you like open up in the back, try poking your finger there, you might get a different kind of zap in the morning. Okay, and also that's why the internal interfaces are being hidden from the user, because they don't need to know those. Right? We just need to know it works, that it brews coffee. Okay, and when you drink coffee, that it becomes code. That's it. Okay. Next is, okay, we'll try to simulate this. This is a more good examples, but I'll move with the online editor because I don't have the ES6, and this one has. So, okay, let's create a class coffee machine. And in the coffee machine, you have the water amount. And it's initialized at 0. So in the coffee machine, it also has a constructor, the power. So this dot power, meaning the coffee machine power, would just get the parameter that was given as an input. And in the constructor, we also want the user to be alerted, or just let's do a console.log. And then created a coffee machine power. And then use the power. And let's see. Oops, not yet. Also, now we can use a let coffee machine, because you want to create a new object from the class machine, because that's just a blueprint. New coffee machine 100. That's the power. Let's see. Where's the one? There you go. Created a coffee machine, and it has a current power level of 100. Okay. Now let's say we want to add water. So you just use the coffee machine, and again dot notation to access the property. Then change that to 200. Let's put a variable so we see what it is. And then it's console.log. There you go. Clear this first and here. 200. You add a water of 200. Now, let's say we want to protect the water amount. We don't want people changing it. And I think now this is another code with setters and getters, and I think this is better than before, than a while ago. So we do have the constructor. Let's remove this. This might be unnecessary. And then let's create a set water amount. Spaces, spaces. And then let's have a value as a parameter. And then if the value is less than 0, throw new error, negative water. Okay. This dot underscore water amount is value. One thing I forgot to change is putting underscore. So other programming language as well, they use this just as a convention. It's not your computer or your compiler won't complain, but as a convention for readability, other developers, when they see this underscore, they would kind of know, oh, you meant to use this as a private or variable. And then, so we have the setters. Let's create the getter, water amount. And let's, again, the getters doesn't really do anything, but just return the value. Mount. Oops. Oh. Okay, we created a coffee machine, and then if we set the water amount, it's still fine, but if we put -10, should not run. There you go. Error, 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 error. There you go. Negative water. Okay, so now you kind of help the, let's say, you have this mechanism that you built for the coffee machine that people can't just add negative water. Okay, because I think you can set these. Is there like a setting in coffee machine that you can put the water level? I don't know. Yeah, so it could be something like that. Complicated stuff. Also, let's talk about the power switch. The power switch, let's see. Let's make it a read-only. Okay. So we start off with, again, we have the setters, we have the getters, we have the constructor, and what do we want? How do we make this as a, oh, okay. So I think with this alone, that's a read-only. So let's try the coffee dot. Oh, we can't even scroll down with this one. Let's fix this. Let's scroll. Okay, let's create the coffee machine again. Post new coffee machine. I don't have my Ninja tabs. Alert. Power is the variable or object or whatever, coffee. The variable coffee machine, and then the power and W for the watts, and C. Sorry, I'd rather use console.log. Clear, run. There you go. And if you want to change the power, coffee machine dot power equals 25. Let's see. It's still run. Okay, that's because we didn't fix the. Oh, okay. Actually, this shouldn't work because we don't have a setter for the power. Oh yeah. Okay. So I think that's it for the getters and setters. It will always be kind of like that you set something, you get something, and you should decouple them and not should be in one function. You never try to do that. And again, I guess one of the things we can just improve this is instead of like set water amount, we can do this, get water amount. Okay. Now we're gonna move on with Modifiers points because it's gonna be super long with the Modifiers point. Someone asked, polymorphism is the ability. What is polymorphism? It's basically an ability of an object to portray different forms depending on how and where it's used. So I do have a example here. Let's see. See if I can run it though. What's that? Oh, this one. Let's try that one. Okay. Watching. Okay. Make this bigger. So basically, as you can see in the code, we created a class car. And then one of the things with polymorphism is you're using this, returning this. And also, because this is TypeScript, you already define what your return type, which is this, which is again the object, meaning the class, the car, return car. Okay. Let's see. Does it has? And let's see how to return this. Okay. Here we have a longer one, but this is easier to understand. Okay. Scrap everything you understand about class-based, because we're now gonna. I'll show you prototype-based OOP, or just using the prototype. One thing to note about this, even though it's so much confusing, based on my research, prototype OOP is way simpler. It's just that a lot of people got stuck with class-based OOP. Again, what's the problem with class-based OOP is like you're always limited with the inheritance. And in the prototype, you can also have like fallbacks, right? And stuff like that. So, oh well, I'll just code and then let's see. Should be way easier to understand. And I believe after this session, you would understand what the prototypes are. Okay, so first let's create an object called body. And in that body, we put a key value, the key. Let's call it init. And we put the value as a function. Again, because function is also a value, you can use it as a value for the key value pairing. And in that function, I want to have a parameter called part. It's a string because we're JavaScript, we can't do the type save. And then let's make this, there we go. And then in the body, what we do always is whatever parameter we get, we assign it to the this.part, meaning the body.part. Okay? And just to check later, let's do this later. Okay. Also, in our object, we can create another key called touch. And in that touch, you can create another value, function, and console.log, you touched this part. Okay, now to use those, you just hit body.init. And what do you want to touch? What body part do you want to touch? Sure, I'll just do nose. Okay, and then, so you initialize the body part with the nose, but you haven't touched it yet. So if you want to touch it, just invoke touch. And so you touch my nose. Oh no. And just to see what this really is, you can console log here and add this. And basically this, again, returns the object. This is the body object. Okay. So next is we can create a new object. Just remove this. And let's see, instead of the value just being there, let's bind them to a variable. No, not that one. Nose. And the other way we do this is comment this out first, and we do an object dot create body. Okay. Now, because the object dot create body is assigned to nose, instead of body dot init, we can do nose dot init, and then we can do touch the nose again. Expected comma. Oh, const. Refresh that. Refresh this. You touch my nose again. Okay. How about something different? Touch my butt. Okay, still works. Let's go back to nose. Let's be wholesome. Next is, so we've used the object.create body. Let's create another one. And then we're going to get there with prototypes. Let's see, no lips. I want to touch your lips. Who wants to touch their lips? And you touch my nose, you touch my lips. Oh no, first base. So the question now is, does the object.create create a copy, or does it modify, right? So the way we try to know that is, let's move things around. This is just to make it cleaner. It doesn't really done anything, but we'll add another one. Right now, extend this more. Let's close this one. Okay. Right now, our body object has the touch key value here with the function, right? What if we want to change that? We can just do body.touch and assign a new value, and we can assign a new function if you want to override. We said console.log, you have yummy part. This dot part, and because we know it's a string, we can access string API. Let's just make it to uppercase. And what do you think would be the output? Would it have the you have the yummy nose, or would it have the you've touched my nose or lips? Yummy? Yummy. Let's see. Correct. So what basically happened there is the object.create, it basically creates an empty object. And in that empty object, it assigns body as the fallback. This is prototyping. Body as the fallback. So what does prototyping do? What it does is, if checks the nose variable, which we created an object, if it has the touch function, use that. If it does not, go look for it, and our fallback is the body. Okay, so again, just to clear things up, basically when this happened, it's as if nose had this same thing. Okay, and then we assign this one, and you were gonna ask, you created a copy, something like that, and you change this, right? And it still happened. So if you're not gonna use the fallback function, what you can do is, let's remove the lips. Let's remove lips. Touch, okay. Do we still need the body function though? I guess maybe not for now. Okay, constant nose.net, touch, body.part. Okay, you never know. So right now, what we're trying to do is we're changing the value of body.part. So what if we want to touch that? I think we also need, yep. You touch my nose. So that's how we use the fallback. If we're not using the fallback, let's say we didn't create the nose dot init. I think we need to go here and go back again. Nose dot init. And then what happened now is because we didn't create the nose dot init in this object that create on, we didn't use the fallback. And then what happened now is you invoke this one and it says, oh, I don't have it. So it goes to the body and says undefined. Then now you assign the body.part string, and then I'll invoke it again. And the nose doesn't have the part, and goes to the body, like, oh, you do have it. So let's use that. Okay. I guess it wasn't really that clear. So basically, what I'm saying is, it always checks first if it has it. If not, go to my fallback, which you declared that, hey, this is your fallback. Okay. Okay. Now you want to confirm if it is a prototype of that thing or that object. So to do this, you can simply use the console.log. I think we need to bring this back. Console.log nose is body.is prototype of, I think, yeah, nose. Let's remove this other one. Okay, so to confirm something, if it's using a prototype, so what you do is you check this one and you ask, is this a prototype of the nose? Is body being used as a fallback for nose? And if you do that, you can quickly check that, hey, it's true. And let's give another scenario. Let's say belly, prototype of nose, uncaught error, because you don't have a belly that you define. Also, another way to check with the false statement is, let's say you have a number, just a weird number, you would get false. Okay. I think I have a second set of example. Okay. So next is, let's say we have a function talk. And in that we have console.log this to check what it is. Invoke that. No, let's not invoke it first. And then console.log this.sound. Okay. And let's say you have let animal talk. So usually what we do is we create a class, right? But this time around, we just create a function. And what we do is we created an animal that says, hey, can you grab the function talk and assign it to my talk? Okay. This comes from this one. Okay. Now let's make the animal talk. So the first console.log, because I just want you guys to know that when you have the this keyword, you get the object. So this is the object. Okay. And because we still haven't defined the sound, it's undefined. Okay. We can also refactor this a nifty way. If you are going to use the same key name to your value name, we can just go ahead and delete this one. It should still work. Even though it's undefined, it worked. Okay. Next, let's create a human. The human, let's say, has a sound, makes a sound, and I know most human makes the sound every morning. Hey, how are you? Hey, how are you? Hey, how are you? Hey, how are you? And let's make the human talk, and this should work or not. Maybe not yet. Nope, not yet, because human.talk is not a function, so we didn't really add that. Okay, so how do we do that? So now we're going to use the object again and invoke another method instead of create. Let's set the prototype of human animal. So now what it means that, hey, I have this object human. Can you use animal as a fallback if the user asks something and it doesn't have it in the human environment? Now, let's see. Boom. Hey, how are you? Again, what happened here, because line number 9 to 11, the human object only have this key value pairing of sound and a string value, hey, how are you? And a while ago, without the object set that prototype of, we're trying to invoke human.talk. But again, human doesn't have the talk function, right? Only animal has the talk function because we grabbed it from the local function talk. And now we're making use of the prototype. Again, it's a fallback so that if it does not see the talk here, it will look at animal. So let's try if we can put human and has his own talk. Let's try to do that. Let's say function console.log talk is cheap. There you go. So now that's what happened. So even though we set this as a fallback, because again it's a fallback, but when we invoke human.talk, human object has these key value pairing, so it doesn't need to look at the animal object. Okay. As the prototype. Okay, let's create another example. Let's create pig. Anyone guess how the pig sounds? Roar. I'll correct you. Abadi, abadi. That's all, folks. Abadi, abadi, abadi. That's all, folks. Okay. Again, human.talk is still going to be, hey, how are you, right? So let's do object.set prototype of pig animal pig.talk. I think this is going to be wrong. It should be talk. I think it should be talk. Yeah. No. After sound, there's sure. Okay, good catch. I think should be sound. Yeah, no, that's correct. Let's remove the talk first. Okay, to recap what happened here is we set animal as the fallback for the pig object. And basically, when we do the pig.talk, the pig doesn't have a talk key value parent, it only has a sound. So what it does, it goes to the animal object and invokes the talk function, and the talk function has the sound. So now it can use the vocals. I think the correct spelling for this one is H, the N, that's vocals. Let's see, what's this? Oh, there's a, okay. Let's create another one. Let's delete our human. We don't need humans. Let's create an angry pig. Let's see. Let's create a key value pairing. The key would be shout, and the value, let's create a function with no parameters. And in the function body, we'd have the console.log. And then let's have the this.sound. And because sound is a string, we can have a uppercase again because it's shouting. And what's that? Let's have the angry pig talk. Let's see. Pig.talk is not a function. Can you tell me why? What did I miss? So I created a new object called angry pig, and I tried to make the angry pig talk. It doesn't talk. Right. So need to put this here. But it's undefined. What is that? Any, why does it have a sound? So again, this is just only a bit tricky. We want the angry pig to talk, right? We have the fallback, the angry pig. No, we have the animal as the fallback. So, okay, angry pig doesn't have the talk. Let's go to animal. Oh, animal has the talk. So let's invoke the function talk. Oh, but in the function talk, it requires this sound. Well, your angry pig doesn't have the this sound. Now that's why it's throwing undefined. Okay. Well, let's still make the angry pig make some noise. So again, no. Can't read the uppercase because it is undefined. Let's remove this thing. Let's see. Think should be undefined again. No. Yes, we have to. No. I think that was wrong. We would have the same output though. Let's say, we should have that. So if we go back to this one, should not have anything. Okay, it doesn't really change. Okay. Now this is more correct because it's just an object and dot notation to access the property as a key shout. Sure. Okay. Should be fine. Okay, actually we're almost done. Okay. Okay, two more, but I won't write this, so we can move on fast. So, one of the muddiest point is, can I think of objects and classes in TypeScript similar to how they work in Java? Yes and no. Do objects and classes really matter much? TypeScript and JavaScript practically, since experts in the field say that usually functional programming, I think the context is better than OOP. I'll get back to this, and because this one asks for like experience, so I'll ask my developer friends. But objects and classes do matter much. But then again, TypeScript and the newer JavaScript doesn't really have classes. Just it's a syntax sugar. Okay. Next is interface topic is a muddiest point. So there's just another, should be easy to understand. So here's the JavaScript code, and it's a temperature. Let's see. And we can just explain quickly. We have a class temperature. We have a constructor. So whenever we create an object of the class temperature, we must pass a parameter, which is a number, and assign that number to this.celsius. And then we have a getter method. So whenever the user info the get, it should get this tag information. Okay. If you want to set the Fahrenheit value, and again, the static is just a way so that we can use this method without creating an object. Okay. And down here, we created a new object of the temperature. We assign that to the variable temp, and we log that out. And this should be the answer, because we just access the object, then .Fahrenheit. Okay, next is, so this is another cool thing that this is, remember, like overloading functions, but kind of like that, but not really, because it has the same function name. But again, in overloading functions, you should have the same number of parameters. So again, it's kind of like overloading functions, but you have to get and set, and then now your JavaScript, when you run it, kind of knows that when you do a temp.Fahrenheit without the parameter, it knows that it's a getter, so it will go to get, and if it has a number, it doesn't go to the setter. Okay. Next, I do have a questions with iterators. So we talk about a bit about adding iterators to objects. Appears to be next.name predefined iterator function of an iterable object. I'm almost 100% sure that's not correct though. I don't know how to really answer that. Can you expound it more? But I do have a code for iterators and has a comment that would show how it's being used. And there's some explanation. Whoa, oh, that's why. So here is an example of iterator. B. So we have an array of dragons, and in the dragons, it's just an array of strings. And next we have the dragons, and it has the symbol.iterator. Symbols are basically just unique keys, weird unique strings to avoid conflicts. Okay, symbol.iterator is completely unique and it won't exist anywhere else. Okay, it also serves as a unique key or property for the object, again to avoid naming conflicts. The iterator has the .next method. Again, I already showed this without running. If you console.log, it shows you the next one. And it also shows you this one, if it's done or not. So when you first invoke one .next method, it will give you a dragon and the dragon, next dragon, until you have enough. If you keep invoking this one, you'll get another value undefined value. Okay. So what is an iterator? It's basically an object that arrays, they spit that out. And when the array spit that iterator out, and then now you can use that to iterate the array. It's kind of convoluted that way. Okay. And basically it just tells the outside world how to iterate on stuff. Okay. And with the iterators, because everything is an object, you can use it to iterate on everything. Like, oh, the example is down here. So you can iterate over characters, and you would have this out. You can iterate over the elements of the string array, which is this one. Okay. before I give you a break, I'd just like to finish the slides quickly. Let's see. And again, if you guys have questions, please ask, because there's tons of ways how to understand stuff. And I know you guys are still the Linux Plus. That's why I'm also hesitant to give you like video resources, more reading resources, but there are tons of cool stuff. So without further ado, let's try to recap stuff. Object-oriented programming with TypeScript and JavaScript. I'm Clark. And so object-oriented, basically it could be a programming language, be a system, a software methodology. Actually, a lot of people has been debating how to really define this. It's a concept of logical objects. It works through the creation, utilization, manipulation of reusable objects to perform a specific task, process, or objective. Coming from the word object-oriented, you deal with objects. Okay? In object-oriented programming, each object is capable of receiving message, manipulations, processing data, setting data, calculations, and sending messages to other objects. Okay? The three principles of object-oriented programming is you have the encapsulation, inheritance, and polymorphism. In encapsulation, you try your best as much as possible to divide the programs in smaller pieces so they would have their own responsibility and not be dependent on one another. Hence, it manages its own state. And you can only change the code around that in one encapsulation. Okay? Interfaces, basically it's the way program interacts with each other and with limited sets of functions or bindings that provide useful functionality at abstract level, hiding their precise implementation. I think this is from textbook. And again, the good analogy is the coffee machine, right? Program pieces are modeled using objects. Okay. An interface can consist of methods and properties. Methods can also be called class functions. Properties are like the strings, objects, and object array. Okay. Properties that hold function values are called methods. Okay. This is from the textbook. That's all about this one. Properties, it could be public, meaning part of the interface. Private, outside code should not be touching it. Okay, you don't want people to keep setting temperature level. We discussed this. External interface example, if you as a coffee addict, you can put the pot, hit the switch, control the water level, but you should never do this, and it's very dangerous because you might break the coffee machine or you get a different level of caffeine. JavaScript uses this keyword. It refers to the object that belongs to it. So whenever you invoke this, you invoke the object that it belongs to. And again, there's tons of other use case for this, and it will be super confusing. Class-based versus prototype-based. So we already told you that an example would be Java, C++, and C#. And prototype-based, there's another one actually. It's called Cell. JavaScript was inspired from Cell. So it's prototype-based. It uses what we've done a while ago, setting prototypes, the fallbacks. Class-based has classes and instances. Prototype-based, it can distinguish classes and instances, only objects. Again, starting ECMAScript 2015, also known as ECMAScript 6, JavaScript programmers will be able to build their applications the object-oriented class-based approach. Even TypeScript allows the usage of this as well. But one thing to note that it's just a sugar syntax. Underneath the hood, it still does the prototype base. Okay? And class is just a blueprint, and then I think this should be objects. Objects create a copy from the prototype. Another word that you can have an analogy is like having a delegate. Okay, someone that can do something on your behalf, hence the fallback. they don't create a copy. Again, they use an object as a backup or a delegate. Okay, if it doesn't exist in human, check in animal or check in person. If I don't have a property, go look in this other object, which is the prototype. Prototype, again, is a simpler concept than classes. We just got used to using the class-based approach, but a lot of people are saying this is better. Okay, I think that's for now. Let's take a break and have the concept test. Thank you so much, and please ask questions. Oh, now, if you have questions, actually, please ask questions. Any? Later? Sure. Let's do that later. Thank you, guys. Too much, right? It's too much. We haven't really gone deeper, actually. We haven't gone deeper. This is just scratching the surface of OOP. But you know, what's good with programming is once you get it, you get it. Many times, right? It's like, I don't believe you anymore, man.
I'm just walking around because I don't want to disrupt Phil over there. Yeah, iterables in any language, the way you actually define an iteration doesn't make any sense. It's like that. Well, no, it's just really difficult to
wrap your head around it.
Yeah, because it's different in every language. They want like a specific way that you define how you do it. So I didn't quite understand the way JavaScript does it. I'm reading more about it now.